Hello folks, let's come back to the miscellaneous exercise, the problem number 13. Problem number 13 is relatively simpler as compared to the problems that we were doing so long. It looks to be simpler. So let's get across the question and see what the question says. Find the points at which the function f, which is given by the thing that is there on the board, f of x equal to x minus 2 raised to 4 times x plus 1 raised to 3 has, they have given the several things. It's very clear to us what we have to do here. First, we will take f of x, get the first derivative, get the second derivative. They have asked us point of inflection, point of maxima, minima and all that, local maxima, minima, so all that we can find out. We can get started right away. Nothing to do much. No introduction as we used to do in our word problems. Nothing like that. First derivative, second derivative, and so on. So let's get started. First derivative, f dash x. Now it's a product. So your first derivative is going to be, it's a product. So u times v dash plus v times u dash, that way. So x minus 2 raised to 4 as it is. Let's get the derivative of this, which is going to be 3 times x plus 1 raised to 2, and then you have to write the derivative of x plus 1, which doesn't occur because not that it doesn't occur, it becomes 1 because derivative of x plus 1 is 1. So that's it, the first part. In the second part, it is x plus 1 raised to 3 as it is, and the derivative of this, which is 4 times x minus 2 raised to 3, derivative of this is again 1, so stays like that. If you carefully see, these two terms have got some powers of x minus 2 common and some powers of x plus 1 also common. So let's take that out. X minus 2 raised to 3 and x plus 1 raised to 2. Let's take that common. In the first bracket, you have 3 times x minus 2 left, and in the second bracket, you have 4 times x plus 1 left. Now check how this comes. X minus 2 raised to 3, x plus 1 raised to 2. This is 3x minus 6 plus 4x plus 4, which works as x minus 2 raised to 3, x plus 1 raised to 2, 7x minus 2. So if we have to take the second derivative, let's keep the first two terms as it is. Take the derivative of the third, which is just 7. Then first and last term as it is. Derivative of the second term, which is going to be 2 times x plus 1. Then these both terms as it is, derivative of the first term. So derivative of the first term is 3 times x minus 2 raised to 2. Luckily for us, they are all linear functions with no derivative of the base we don't have to account for, because they are all linears first of all, and second thing, the derivative of the base is just coming up as 1. So that solves most of our problem and doesn't make it so complicated. So you are there with f dash x and f double dash x. Now let's go to the critical point. So let f dash x be equal to 0, which means this: x minus 2 raised to 3, x plus 1 raised to 2, 7x minus 2 is equal to 0. The products are 0 means each of them have to be 0, isn't it? So you have to account for all of them. So here you can have x plus 2 0, you can have x plus 1 0, sorry, x minus 2, and then 7x minus 2 0. So when we look out for this, x can be 2, one critical point, x equal to minus 1, another critical point, x equal to 2 over 7, another critical point. So the 3 critical points you have got. Now we will look out for the, from the second derivative, find out maxima, minima and so on. If we carefully observe, in the second derivative, we have got x minus 2 and x plus 1 everywhere. So if we try to put the value 2 and minus 1, you will get f double dash x as 0. So whenever you get the second derivative as 0, we are not able to conclude whether it will be a maxima or minima. It's not possible to conclude. In cases where you get the second derivative 0, it's better you go for the first derivative test. Actually, there are two tests for checking the maxima minima. No? So maxima minima basically is done by two tests. First is called the first derivative test, and this, what we do always with the f dash, is called the second derivative test. Now second derivative test is okay for, in this problem, it's okay for some critical points, but it is not okay for these two. Because if we put x as 2, you can observe, if we put x as 2, this will become 0, this will become 0, this will become 0. So the entire f double dash becomes 0. Second derivative becomes 0. We're not able to conclude whether, what would it be. So also, if you put x as minus 1, this term is 0, this term is 0, this term is 0. Entire f double dash x is 0. So we are not able to conclude, anything about the function. So because the second derivative test is failing there, we will switch to the first derivative test for those 2 points. For this point, I think it's okay. It will work. So either that you do all the 3 points with first derivative test, or because it's working, second derivative test is working for this, we can do it for that. It's all one's own wish of doing, and nobody tells you that you have to take this test of derivative. You can take any test and find it out. So therefore I will do both so that you get a flavor of both. As I told you, for 2 over 7 second derivative test works, but for minus 1 and 2 first derivative test will work. So we'll do both. So we are going to substitute, isn't it, here or now let's look out for f double dash at 2 over 7. That's our f double dash value. So 2 over 7 you can quickly see. So if you put 2 over 7 here, this term is going to be 0. This term is also going to be 0. So you are going to get only the first is the surviving term. So here you will have 2 over 7 minus 2 whole cube, 2 over 7 plus 1 square times 7, and other terms are going to be 0. So just look at this. Actually, you don't need to find the value, you just have to get the sign. So if we carefully look, this is going to be 2 minus, when you equalize, it will come to 2 minus 14 over 7, which is going to be minus 12 over 7. Because it's a cube root, that negative sign will stay there. So here this is going to be negative, this is positive, this is positive. So overall sign is negative. Therefore, what they ask us? Do they ask us a point? What do they ask? Okay, where is local max? So we can write here. There, what is that? This is maxima occurs. And x equal to 2 over 7 is a local maxima point, because they ask us like that. Yeah, they ask us what's a local maxima point. So one thing is done. Now, as I told you, only for this is working. So for the other two, it is not working. So there we go for the first derivative test. And to check the first derivative test, first you look at x equal to 2. See, first derivative test is, if it is x equal to 2, you take 2 points on either sides. That is, you take 1.9 and maybe 2.1. Of course, in that range, you can take any 9.05, something like that, in that range. That's close to 2. And you substitute for your function values and see how f dash values, and see how f dash is changing. If it's changing from positive to negative, then it's going to be maximum, and vice versa. So that's what it is going to be. Yeah. So let's do the checking once again. Yeah, one minute. I will just small confirmation. Yeah. From positive to negative, then it's a maximum. If you get the f dash value from positive to negative, then it's going to be a maxima point. Okay, so let's look at f dash at 1.9. F dash at 1.9, we're not again going to sit and substitute, but we are just going to check the sign. So f dash at 1.9, if it is, then it will be like this. It will be 1.9 minus 2 raised to 3, 1.9 plus 1 raised to 2, and 7 times 1.9 minus 2. Now check how this sign would be. This is anyway positive. This is going to be positive. This is because it's a square, it's positive. And this is going to be minus 0.1. Yeah, minus 0.1. So this is going to be negative. Overall sign is negative. Now, f dash at 2.1. On the contrary, is going to be 2.1 minus 2 the whole cube, 2.1 plus 1 the whole squared, and 7 times 2.1 minus 2. So this everything is going to be positive, because this is positive. Actually, this is the problem. And this is positive, so the entire thing is going to be positive. So you are moving from negative to positive. So it's going to be Yeah, it's going to be, that's going to be a point of, see, you're moving from negative to positive. So it's going to be a point of minima since f dash at 1.9 is negative and f dash at 2.1 is positive. Therefore, minima occurs. So, local minima point is x equal to 2. Yes, that's your local minima point. Now it needs for us to check x at minus 1. Same way. So just look at negative 1 over here. Negative 1 means over here and over here. So you can have maybe on this side you will have negative 0.9 and on this side you'll have negative 1.1. That's how it goes. So let's see how it goes. F at negative 1.1. Let's see how that goes. F at negative f dash at negative 1.1 is negative 1.1 minus 2 the whole cube, and then 1 negative 1.1 plus 1 the whole squared, and 7 times negative 1.1 minus 2. We need to see this carefully. Now this is going to be negative value, so this is going to be negative, sorry, this is going to be negative, this will be square, so positive, don't have to be worried. But here this is going to be negative, and so this is going to be overall negative, so it is going to be a positive quantity because two negatives are there. So also let's look at f dash at minus 0.9. At minus 0.9 you are having minus 0.9 minus 2 whole cube minus 0.9 plus 1 whole square. That is not a worry to us because it's a square. 7 times negative 0.9 minus 2. Now see, this is a negative quantity. This is also a negative quantity. Again, this is also positive. So both are positive. So because only if one is positive and negative, then we are able to conclude. When we are not able to conclude, we call it as a point of inflection. Since these both are positive, or if both are negative, then we call it as a point of inflection. Therefore, x equal to 1 is a point of inflection. Inflection means sometimes your graph will go probably, suppose where is this? Negative 1. So negative 1 means your graph goes, like this. Not that way. But all this means maxima, minima means either like that or like this. Not like that. This will go this way. That's the meaning. So that's about it. So we have not, actually it is important in the sense why, because we had not done many first derivative test, we have not done at many places. So here we had an opportunity to do the first derivative test also. So sometimes there are stray questions in the exercise where they ask us to do first derivative by first derivative. So if at all such a thing comes, we know how to do it, right? You take the first derivative, check if it's going from positive to negative or negative to positive. If it goes from positive to negative, it's a maxima point. If it is going from negative to positive, then it's a minima point, as we got here. From negative to positive, it meant it became a minima point. If nothing happens, it's a point of inflection. That's it. So that's about this beauty of this problem. Simple, but the concept is there. Now, with the next problem, we'll meet in the next video. Thank you.